Over the past few decades, safety improvements in the construction industry have resulted in a significant decline in construction injuries. However, in more recent years, data has revealed that despite the fact that injury rates have continued to decline, the fatality rate has appeared to have plateaued. In response, the Construction Industry Institute has formed a research team comprised of 25 industry members and 2 academic research professionals in an effort to prevent these catastrophic construction workplace fatalities. Other industries such as NASA, the nuclear industry, and the aeronautical industry have found great success in preventing their respective industries' catastrophic accidents via a precursor analysis program. By leveraging precursory information, these industries have taken a proactive approach to safety by predicting fatal injuries that are high impact, low frequency, or HILF, in order to prevent them. Unfortunately, direct implementation of these industries' precursor methods is infeasible due to construction's dynamic, complex, and fast-paced nature. In an attempt to solve this challenge, this research aims to address the following essential question. Are there precursors of HILF events? If so, what are they, and how can they be identified, analyzed, and used in a predictive fashion in order to prevent the occurrence of HILF events? Our mission is to conduct rigorous research that improves the construction industry's ability to identify and analyze precursors of HILF events proactively. In the past, the primary barrier that has prevented advancement in safety prevention of these HILF accidents is the very nature of the events themselves. HILF events happen too infrequently to have any predictive relevance. To address this issue, both the size and resources of the research team will be utilized, as well as the concept of high energy. High energy will be used as a gateway to distinguish situations that have the potential to be a HILF accident from those that do not. The reason being that those situations that involve high energy contain the largest potential for a fatality. With this said, high energy work can be subdivided into 3 conditions. These are 1. High energy work that resulted in a fatality or life-altering injury. 2. High energy work that could have resulted in a fatality or life-altering injury. And lastly, 3. High energy work that was successfully controlled. The first 2 conditions constitute a HILF event due to the fact that luck was the only differentiating factor between the 2. The hope of the research is to be able to predict the occurrences of these HILF events using a small number of precursors and/or combination of precursors to prevent the occurrence of severe accidents. To accomplish this ultimate goal, a 5-phase research plan has been proposed by the team. As is tradition in research, Phase 1 will involve the leveraging of existing knowledge by means of a literature review, which will look to uncover useful precursor analysis techniques that have been researched or used by other industries. Concurrently, the team will begin Phase 2, which will involve the gathering and analyzing of public fatality reports from various sources in order to initially identify potential predictive factors. Once the public fatality reports have been analyzed to the extent they can be, the team will move into Phase 3 of the research plan, which will focus on creating a list of latent factors not necessarily identifiable in the public fatality reports. Identifying these latent factors will be based on the experience and expertise both from within the team as well as from outside experts. The bulk of the research plan lies in Phase 4, where an iterative experiment will be performed to test the predictive powers of the factors identified in Phases 1 through 3, along with uncovering new factors. The experiment will begin by team members gathering extremely detailed information for events that qualify as one of the 3 high-energy situations introduced earlier. These reports will be submitted directly to the academics of the team, who will in turn strip all information pertaining to the outcome of the events and redistribute the now undistinguishable high-energy situations to the team. From here, the expert team will evaluate these high-energy cases using the initial and latent factors, in addition to any other factors they may uncover, in order to try and predict the outcomes of the events. After several iterations, the team's success rate in predicting the outcomes will hopefully improve to be greater than 90%, in which the predictive skill of the factors will be assessed and either rejected or accepted as precursors. Although the experimental design was purposely designed for self-validation for ethical reasons, the last phase of the research plan will be field validations and implementation. which will accomplish the goal of evaluating the feasibility, the resource requirements, the best practices for implementation, and the perceived improvement of the research. At the conclusion of this research, the team hopes to produce guidance to identify and analyze precursors, latent precursors and pathways, examples of precursors, thresholds for alarm and action, an improved system for injury incident reporting, and finally, a catalyst for proactive safety management that will save lives and prevent catastrophic construction workplace fatalities.